All right, we are on air.
Assalamualaikum warahmatullahi wabarakatuh. Hello guys, come back to our podcast, which is Sunday podcast, and now it seems that now it's time for Haskuti or India to perform or talk about exploring mathematical operations and cluster cross number sets. Well, that's quite interesting. You might take time to explain about yeah some of mathematical data in the kind of symbols of these equations.
All
So
right.
well, yeah, it's time for you to talk.
Yeah, I mean, it's kind of. I mean, it's going. I'm going to talk about mathematics. Some of you which may or like it. Some of you which may doesn't really tend to be like math. Like people are different. I know, but I try this to be. I try to explain it as much as fun as possible while maintaining the education part. Perhaps I don't know. Let's just check it. The where is it? Oh yeah, there you go. The slide. Can you see?
Loading.
Yeah, it's still loading, but
All right, I
I
can sit now.
yeah, it's okay.
All right. So we try. I'm going to explore mathematical operation and closure across number set. So I guess it's kind of hard. It's a weird title, It's to some people maybe this is to people who doesn't have mathematical background. This is going to be a very obscure title out of hand, right?
Obscure.
Yeah. So, but let me show you that this isn't that much of. You don't need higher math education to understand this. So motivation, all right. So imagine you're doing mathematical operation, addition, subtraction, multiplication, division. You may start like at a natural number, right? Like this: 3 + 5 = 8, right?
Right.
And that's it's so simple. Like 2 + 2 is 4, 1 + 1 is 2, etc. However, you will encounter problem if you start subtract. You try to subtract bigger number than the first operand. For example, like 3 minus 5 equals -4. But however, -4 is not part of natural number. Natural number is 0, 1, 2, 3, 4, and so on, right?
Wait. Hold on. Why is it -4? Isn't it supposed to be
Oh
minus
yeah,
two?
sorry. This is actually supposed to minus 2, I guess. Sorry,
Okay,
yeah,
okay.
-2. Yeah, but the point still stands though. This is actually
Adil,
-2.
I mean, Askuti is trying to uh, collect our attention.
Yeah, yeah,
Oh.
yeah. By making mistake, I
Oh.
try to gain attention.
It is planet. It has been planet.
But no,
It is
I
it is
haven't
set up.
planned.
It is set up.
I mean, I haven't planned this to be fair, but yeah, it's kind of good way to bring attention to
Tension is
the
all you need.
listener. Attention is yeah. So what I mean is -1, -2 is not part of natural number. Uh, Hence, we need to invent a new type of number, right? Like minus stuff, like -1, -2, -3. This is extending natural number to integer. This is actually not the integer symbol, actually to be z, right? I
Okay,
mean,
so alright, okay. Wait, what? Why
but
does is it E then?
I yeah, to gain your attention. But
Steal
no,
attention.
no, no, just kidding. Yeah, but I made it wrong, I guess. But is that enough for all math operation? What do you think, Andrea?
Well, of course, there are many math operations and it is, you know, rational number, irrational
Right.
number,
Hmm.
and imaginary number in you know.
That's true. Yeah, well, I mean, for example, if you use division operation, we encounter 3 divided by 5 is 3 irrational, 3 divided by 5. I mean, a fractional number, basically. It's not part of integer. We need to extend from a set of z integer to rational number q. Is that enough? No, right? You have square root, which is not an element of uh, no, sorry, this is not, yeah, it is not a fractional number, not rational number. We need to extend from q to real number,
Oh yeah, real number.
real number, then we have this fraction, square root of -1 is
What are
I.
the difference between integer and real number?
So for example, pi, Andra, pi 3.414,
Yeah,
etc. So you cannot create fraction from pi, right, Andra?
fraction from pi.
Yeah. Like 2020 divided by 7 is just approximation of pi. We cannot. So it is a real number. It's not a rational number. Pi is not. Yeah, that is pi. Yeah. So after that, after a real number, so square root of 2 cannot be defined with rational, right? I mean, there are some proof there, but let's imagine that this is true. Like, however, this is not enough for all math operation. Square root of -1 is I. Sorry, if you don't know, like square root of -1, and especially for someone who doesn't have math background, like there are no number that can be that are the answer from square root of -1. So we use another name like I, perhaps. Then we extend this real number to complex number. Well, is that enough? And you can go on and on. Maybe you find some number that doesn't inside of a set, like that's the question that I want to answer. Like, what defines a mathematical operation, and how much set extension do we need to cover all mathematical operation? Right? Maybe some concept first. You have function, right? Function is just an operation for Adil, who have computer science background. Function is operation that takes input and process to output, right? In math, function is just a mapping assignment from an element in the set to another element in the set and another set. Kind of like this. Yeah. I should probably just going to hold on a little bit. I'm going to use window rather than entire skin, rather than. Can you see it?
Oh, yes, it's
Yeah, something like
already
this.
clear.
This is a function, to be fair.
Oh yeah, this is
Yeah.
relation, isn't it? What's the
Yeah.
All right,
also
all right.
relation?
Yeah, relation, an assignment from one element to another element. That's for another interset, perhaps another set, basically. That's a function, or maybe that's simplify a function there. Yes. Next, we have mathematical operation. Mathematical operation is a function, basically, but it's input and unary, binary, and more. In this podcast, I'm going to show just a binary operation: addition, subtraction, multiplication, division, and exponentiation.
Binary, all right.
Binary means you have two inputs outputting one value, basically. That's fair, right? I mean, closure. Now, closure is just operation is said to be closed. Like if when you apply that operation, the result is also in the same set, basically. Like, for example, if you have natural number and you apply operation addition, like adding two natural number, the result should be in natural number also, right? But however, like if you try like division, like natural number divide another natural number, it doesn't go into the natural number because it creates a rational number, not a natural number. It's not part of natural number. So far, do you get it?
All right. So
Oh,
there's
yeah.
this closure,
Hmm.
and then if it is also in the same set, it is a
Is
closure.
it close? Is it close if it's when you apply that operation and it's still in the set that you have?
Oh, closure is like a programming language.
Oh, it's closure.
So
Is that
it is different. All right, all right, all right.
okay? But so we have this table, right? We want to have some like kind of exploring which one is close, which one is not close. So natural number. How about natural number? What do you think?
Well,
Adi-
everything is
Andre.
closure, I guess. No, no, no. I think,
Addition,
Addition.
yeah, addition is of course closure.
close is close.
Of
Yes.
course.
Close.
Subtraction,
No, 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 it isn't.
no. Multiplication,
Yes.
Close.
division,
No,
no. Nice.
not close.
Exponentiation,
Uh, exponent.
like if
Not
a
not close.
not close. If a exponent by b,
Yeah,
both of them are natural
yeah,
numbers. Does it
close.
close? All right.
Oh,
So
yeah.
close, not close, close, not close, close.
Yeah, maybe something like that.
Let's check. Oh fuck. Yeah, sorry. It is, but integer is also. I forgot to close this, but yeah. That's what happened. I guess close, not close, close, not close, close. Now integers. I want to quiz you, but I guess the cat's out of bag. So integer is close, close, close. However, division is not close. Exponentiation is not close. Why?
um,
Why I mean, division is kind of easy, right? You can give me some example why division is not close.
I mean, like,
Can you?
um,
Okay. Hmm.
uh, wait. Yeah, I
Okay,
think this is Andra.
Andra, can you tell me why integer is not close in division?
So, uh,
Just give me some example. Just
Okay,
one example is fine.
so do you think that integer is numbers
Mhm.
that is not decimal or
Integer is an integer like -1, 1, 2, 3, 4, 5, 6.
so -5 is one of integer examples.
Yeah, that's it. But it's not close under division.
It's not close under. Okay. Yeah, because I mean like it
Adil,
might.
Adil, be prepared. I'm going to ask you exponentiation. But
Well,
yeah,
it
continue,
is
Andra.
very easy, I
Alright,
guess. You know,
Because the way how division works in integer is the same as the natural numbers.
That's true. It best that you show one example. For example, like if you have, well, integer is, for example, like one integer is 3, another integer is 5, and if you use division operation like 3 divided by 5, it's not going to be close, right, under division, because 3 divided by 5 is not integer, right? That's how it works, basically. Yeah, how about exponentiation? Can you show me example, Andy?
it is 2 power minus 1.
That's correct. That's to the power of minus
It will
1.
be 0.5, and 0.5
It's 0.
isn't an integer anymore.
Yeah, the definition of power in the negative number, it's going to be like a rational
Division.
number.
Yeah,
Division,
division.
basically. Now, how about rational number?
Okay, it is close, of
Close.
course. And then close again,
Close again.
close again. And then for division is kind of hard. Let me think about it. Pi, let's see. Can it becomes a real number? No, no, no. Pi isn't a real pi isn't a rational number.
Why is not rational number?
So
Can it?
rational number is like, hold on. I don't think rational number. Wait, Andra.
Yes.
Can you help me about this?
Is rational number close under division?
Oh man, I mean I forgot. How can you define rational numbers?
Rational number is not this. I mean, decimal could be, but it's not decimal. More like if you have one number, divide one number, another number, it is like rational. For example, like like half, 3 divided by 4, 3/4, like something like this. Okay, LaTeX online. I mean, basically, what I mean is like a fraction, you know.
Oh yeah, all
Fraction.
decimal doesn't mean rational number. That's right.
Yeah, for example, like 3 4, 3.5, 3 4, 3 5. I mean, 2 1 is actually like a fraction rational number too, as long it because it matched, right? Yes.
So
So
the rational numbers mean all or whole numbers that um, you know that are not decimal.
Yeah, I think it is
it's
close.
kind of like it's something like this, you know. The structure is like this. You have two number A and B, and you can choose whatever number it is. I mean, it's a natural integer in here and integer in below, and you divide it. That is rational number. For example,
Yeah.
to divide 7.
How
This is
about
a rational.
4?
27 is kind of a rational number example.
This is rational number.
How about 5 divided by 3? It is 0.1.3333333. Is it
What 1
4,
divided by
4,
3?
4 divided by 1 divided by 3?
This is a rational, still a rational number, right?
Also, it
Because
is 0.333.
it
So what,
doesn't. Oh
what
yeah,
about irrational? What about irrational one?
this is still rational number because it can be expressed by this structure.
So what about the irrational number example?
Irrational number, for
Pi.
example, like pi root 2 actually.
Yeah, also root 2.
Okay, I don't.
Irrational.
This is QWERTY.
No.
This is not
you,
a
you
rational number. This is irrational. It's root 2,
Irrational. Okay.
3, or maybe
Square.
pi.
What about square root of 4?
Is 2. No, it is integer.
is Euler number rational, Ren?
No,
Oh,
it's
it's
not rational.
irrational. I see.
It is irrational. So back again, what about
Okay.
this? Is it rational or
Close,
not? Is it close? Close. Okay, how about exponentiation?
Now this one is
What?
interesting. Um, hold on.
I already hint. I already show you before.
Let me see. 2 power. Um, wait. Minus is basically. Wait. Wait. Hold on. How do you make? Wait. Hold on. Hold on. Wait. Hold on. 2 minus 1. 2.
Close, 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 close. This is
Oh
close.
no,
And
irrational. Not. It is not close.
this is not close. Why? Can you give me an example?
Like 2
Mhm.
power 0.5.
That's right. And yeah, that's true. Close, close, close. And this is not close. The way that you tell me, because you know, if it is close, is you kind of have to prove it, right? It's harder because if it's not close, you just show one example of it. It doesn't close. But if it is close, it's kind of you need to
Yeah,
prove something
it
different.
is harder to prove close.
To prove it, you actually can use like since division is the inverse of
Yeah.
multiplication. So if you use division of rational number, you just basically like flip the number there. For example, like if
Is it
like say
multiply contradiction?
no, like for example, if you have this one, uh this is I'm not liking this, like 3 and 5, 2 and 3 and 5, something like this, right? Division like this, right? You can actually like just not this, like just flip the bit the numerator and the
Yeah.
that's why it is rational, right? And you know that this is actually close, right, in multiplication, so it is also close.
Oh, I see.
Yeah, so you just flip it for 4 divided by 5 to 5 divided by 4. That's how you know that this is actually close, irrational number.
No, this is the
No, real one.
wait.
Real includes pi.
yeah, this is yeah, close, close, close. What is
Close,
it?
close, close.
And then Andrea, what do you think about multiplication?
Real one, right?
Real. Real means pi, and pi is irrational, but it is a real too.
Uh, Division, not close, maybe.
Division not close. Why? Why? I mean, you can say close or not close, but you have to show me why. Right? I mean, you can just tell me that this is close, this is not close, but you don't show me why. This the math in math community, like a researcher in math, PhD research and stuff like that, you have to show why. Like you have to give some insightful reasoning why this is true or not, like logical reason why this is true or not. If you just because if you just claim it's not, it's just a proposition, hypothesis, or maybe just some kind of conjecture, like give a logical reason why this is true or not. Like addition, close, right?
Eh,
Real subtraction is close,
yeah,
right?
close. I say close, right? Isn't it?
Is it not close? I didn't, Andre?
I think it is close
Close, close,
multiplication.
yes, close, close.
Close.
It must be close.
Division.
I bet
This
it's
is
close.
going to be hard.
Division, is it close or not?
So let me think. Pi, pi. There is this beautiful equation that I kind of think about it. Most beautiful equation, Ren?
E to the I pi equals 0.
Yeah, that one. Uh, I think, it isn't. It is still close for division. Yeah, or is it?
How about rate exponentiation, if that's may easier
Close.
for
I
you?
bet it's close.
Right? Exponentiation is close?
Yeah.
Hold on. Hold on.
Really?
No, 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 no. It isn't close. It is easy for exponentiation. -1 power 1/2. That's
0. Yeah, that's not
yeah.
close.
That's close.
But for
Act-
division, I am not really sure.
So actually, yeah, that's true. The explanation is easier because you already seen the previous example, like -1 power to 0.5, like the square root of -1 does not have, it's not in the real number, like it's actually the complex number. So actually, it is
Oh, yeah,
close
it is close. I see.
because you can define it in, for example, like you can define it with limits. Like for example, if you
With
let's
limit?
say, yeah,
What's
I mean, okay, for example, if you try to define some rational number, for example, like pi divided by, okay, frac, uh, p divided by e, basically, you can use some kind of like limit to approx, not just to approximate, since real number actually is hard to approximate. Like you can like use limit to approximate more better each time.
Oh.
For example, like this one,
Limit.
you basically can, like, I mean, you can try it by using just a normal division method, I guess, but it's kind of hard to explain. But pi is some number, and yeah, you just divide the decimal from the left side to the, so 3.1415 etc., and divided by 2.7, etc. You just like you divide this one first, and then you continue as you go forward, basically.
Oh, you use
The-
that. I kind of Godel one, right?
Gödel, I don't know, it's called Gödel one.
Hilbert Hotel.
I mean Hilbert Hotel one, but it division on real number. I mean, you can search it basically. Yeah, but it is actually like another real number.
Oh, I see. Alright then.
All
But
right.
do you mean that
Last one.
clause here means that
The
for
result,
example, yeah, the result is the same as the set before.
yeah, the result is also real number.
Oh,
Result, or for example, like this one, addition natural number added to another a natural number should be
yeah,
result be another natural number. Three plus
yeah.
four is
All right,
7,
got it.
and this
But
one is not because
real numbers cannot work in exponentiation
it.
as was.
I mean, yeah, this one is because, for example, like this, if you exponentiate uh, square root of one, not no sorry, root square root sqrt 1 minus 1, you can see why this is not you cannot do that because square root of what is the square root of minus 1, Andra?
Oh,
Like,
I get what you mean. I mean,
mm,
it must result. It must result either minus 1 to the power of 2 and 1 to the power of 2.
yeah, I mean, I guess that's
Uh,
it. I mean,
Resulting either minus 1 to the power of 2 or 1 to the power of.
oh no, I think that's not. I mean, basically, what I'm trying to see here, like, is there a number a times a equals minus 1?
Equal minus 1.
Yeah.
A
The
well, I mean,
problem,
it's there's not such a number to be defined in this case.
there are no number, right?
Because
Because you,
1 times 1 must be 1, and minus
yeah,
1 times minus 1 must be
yeah,
1 too.
yeah. That's there no exist. There are that it doesn't exist, right? Like
Wait,
a number.
that's
Hmm?
right. Um, root minus 1 times root minus 1 is 1 or minus 1.
What do you mean?
So I times I
Hmm.
is
Oh, I, yeah.
is minus 1 or 1.
Now, so the truth is like so since we do so for this example we don't have like the so it's resulting to 1 rather than negative 1. We use a placeholder number called I. Just imagine that this is exists. This is why it called imaginary number. Imagine a number I. When it times itself, it result to minus 1. So this is imaginary number called I. Like you ideal said that if you try to do this, it should be equal minus 1.
Or not 1.
Hmm?
Why not 1?
Because it is how we define it. Like the square root of negative 1 is I.
All right, so
But
it
it is,
so,
you know, if we, well, I don't know.
so in
You-
conclusion that exponentiation will be unclosed for real
That's true.
number because square root of minus 1 is not real numbers in the result.
Yeah, because it is not a real number.
All right, so
I still
my question is so what is the answer of square root of minus 1 if
it's not
it's not
close.
real number? So it's gonna be unreal numbers.
So it's not close. It is we define a new type of number called imaginary number, mix it with so imaginary number. Imaginary number is literally means like this, like you create a new number where I is square root of minus 1. So you have this I imaginary number square root of 1, and then you just combine it real and imaginary to create a complex number, which is
Oh, okay. So
real.
such a numbers.
Yeah, there's such a number, which is useful in sometimes useful in practical context, but to us is to mathematician is just a
So imaginary numbers means it's not real one.
It's not real. Yeah, basically it just meant it's not real.
It's a
It's
Okay,
fake
just
so
one.
more, just
It's a
just
yeah,
fake.
a,
and, instead we solve the equations. We'd rather put some variables to real numbers
hmm.
to fulfill the comfortability.
Yes. For example, like imagine you trying to solve like a polynomial, for example, x squared equals minus one, right? I mean, you will not have, you are not going to have, uh, you will not have answer if you just use a real number there. But it does, if you try to use imaginary number, a complex number in this case, you will have an answer there. Like this is going to be x going to equals I basically. Uh, a right arrow. Yes, something like this. So far, you do you get it, Andrea? Adil, do you
Yeah,
still have
I'm still
question there?
here. Yeah, I guess I'm still here. And by the way, for the complex number, I guess all of them are close, right? I mean, this
That's
should be meta. Should be the highest
that's
one.
true, actually. Yeah, this is actually close for all of them. Exponentiation is kind of crazy. I to the power of I, actually it is in still in complex number, so it is close. For example, like division is still close. Division is still close because it doesn't matter. Yeah, so this is all close, basically complex number.
Kind of wondering, Ren, is there
Mm.
something higher than exponentiation?
There. Good question. There are operation more than exponential. It's
What?
called tetration. Tetration is to the power of much more. Like for example, like in so this is example of addition. Addition is 1 plus n is equals a plus 1 plus 1 plus 1. There are multiplication. N times a is n a plus a plus a plus a n times. Exponentiation is a times a n times, right?
Mm.
There are tetration, which is a tetrate by a and so on, and
And is there
operation.
even meta than tetration? Is there
There are actually
there is
they are. It's called hyper operation
and then
here.
is there even more meta than that?
Yeah,
Well, it's kind of
there is
an iteration times.
the way that usually the general form it is called Knut. I like when you use Knut, Knut up arrow notation. Uh, so a single one is just exponentiation. To arrow 4 is to exponent by 4. Double arrow means tetration. It's called the third one is actual pentation, but to arrow 2 is 2222 to 116 and 64. Pentation. This is pentation. Triple
Oh,
arrow is pentation.
is that what you
So
mean as tetration?
this is tetration. To tetrate 4 is two to the power of 2 to the power to n time 2 4 times. Pentation is basically uh so this one so to the power the pentate to 4 is how should I, this is going to be hard to explain,
Yeah, it's
but
just
this
super
one
simple.
is of 2 basically. So this is the number of the stair here is going to be to the power to the third trait of 4 basically. So
But
this is have
the basis of this kind of tetration, when you wrote it, you get that the basis is from addition, right?
yeah, the root is from addition, of course, but yeah, this is operation, binary operation, but this is not a simple binary operation anymore. Like in terms of radicality, this
That's
is
why,
going to be in hyper operation.
that's why in either uh, binomo you may
Binomo.
multiply
Binomo.
around gain, yeah, or capital into iteration like this
Well,
because it's binary option.
I
Ah.
got that. Yeah, I guess. Like I got
Ah.
the joke. Yeah,
Oh, that's
it's
a
really
joke,
much.
right? That's not serious, right?
Yeah, I know. But
Or is it?
yeah, but yeah, but to summarize, yes, there exists hyperoperation, Adil,
Yeah, yeah,
pentation,
I agree.
hexation,
But
and so on.
shouldn't we also include it in the whether it is a closure or not?
Now, here's the problem. When you search titration, we actually don't know if it's close or not.
Oh, why do we don't know? Oh, there's no proof yet.
There's no proof yet.
Oh, that's quite interesting.
So if you want, I mean, there are analytical continuation. That is a field of mathematics that tries to extend. Sorry. It's not. It doesn't have a proof yet. Rather, it's more like we don't have a definition of titration for example, like, do you have any definition for titration? The titration is easy for natural number, right? Because the iterated, like for this 2 to the power of 2 to the power of 2 to the power of 2, right?
Hmm.
4 times, right? But how about if you try to change this 4 into like half, like one half, 0.5? How do you iterate this? Like,
What?
you don't, yeah, how do you even define 2 to the power, the tetrate 0.5 or half?
You just said
Because
the
Oh,
you cannot,
power.
oh
yeah,
yeah,
you,
that's right. You cannot
yeah, you, yeah, we don't have definition for
definition yet.
titration. For that's why it's not we don't have proof. It's more like we don't have definition for it.
Oh,
Like, the definition could be many things, or it depends on people. Yeah. So that's why we don't have really titration. We don't include it in here basically.
Of a half.
So yeah. So I'm going to show you a Venn diagram of set number. I think I already can show you. Is it? Yeah, something like this. Is that
Okay.
you have natural number, integer, rational. This is cool, right? I mean,
oh yeah.
Yeah, it makes easier
yeah,
to
to understand.
identify.
So you have rational number, 1/2, 0, -2. So we have natural number, the things that we know. Integer is the -1 included by this. Rational number is rational, one.
What are the difference between real algebraic and real numbers?
Real algebraic is far, like, you can use equation to understand real algebraic. Like, for example, root 2 is actually like this. Root 2 is, imagine like x by x equals by 2, something like this. You can actually solve this, right? And you get root 2, right?
Oh yeah.
Right arrow, x equals square QRT 2, right? That's what happens, right? I mean, okay, after that. Yeah, something like this, right? This is also true for 3 and 4 and so on, basically. Back again. So yeah, so root 2, root 3, 1 plus root 5 divided by 2 is you can see how I can create an equation for this, right?
Yeah.
But for pi e minus 2 pi, I cannot, because you cannot create a finite equation for pi. Only approximation. Pi equation. Yeah. So pi is actually defined like this. No, sorry. This is, yeah. So it's
Do you mean pi is a circle?
yeah, pi circle p 3.4.
No, it isn't a circle. It is 2 pi if you want to become a circle.
Oh yeah, yeah. I mean, it defines for a circle, like this one, like this. This is how somebody can define pi. It's iterated, like it's not a finite equation. There's
Yeah.
always
We can
be
also use
more.
Mac-Taylor series.
Yeah, Mac-Taylor series is also yeah,
Okay.
that's true. Applied, can be applied. wow, how do I? Where is it? Like this one, right?
Oh yeah, yeah, that one.
Yeah, that's true.
So how
Yeah,
can 2020 be achieved?
I mean it's just approximation, and it is a good approximation to be fair.
Oh,
Uh,
really?
yeah. Here integer is 3. The fraction could be 2020 divided by 7, 333, 0.06, 106, and so on. Digits are, you see digits and so on. You can see many things on this. Wikipedia is a strong, strong, a strong information. Sorry, a good information.
Yeah, if
Ability.
you claim that mathematics is an exact course or subject,
Mhm.
however, why do they have some of approximation like that
Oh,
is does that mean that mathematics sometimes casts doubt on his result?
yeah. The problem is we can define it. We know there's a number there. However, you cannot be expressed by a common fraction. That's the problem here. You cannot express pi in the normal way. Like for example, like if you can express it like this, that would be fine, right? It will be nice, right? But however, pi it shows that pi cannot be expressed as that. Instead, we can express it in something more like uh, if you something like this, they have pattern there. However, there exists pattern here, but the pattern doesn't. The pattern is not close. I use close again, but it's not close to a finite amount of
The
equation.
number.
Yeah, number basically. Yeah, that's why we use approximation to, well, I mean, it depends on people. Do you want to use, so for example, like pi in 6 digit is enough for calculating the diameter of earth, with pretty
Wait.
good
Do you believe
approximation.
that Earth is actually round?
Oh god.
Ah, you
I don't
you
know.
go good.
I don't know, maybe. Well, and in any case, yeah, that's why pi is not. So we have a name for a number that cannot be expressed as an equation algebraically. It's called a transcendental number. We,
Transcendental. All right, all right.
yeah, it means that you cannot express this as an equation, or in rigorous math, it's called, you cannot express this in algebraic form. You can use algebra to derive e or pi. That's exists. Now, I want to show this one part of unsolved problems. Sadly, e times pi, e plus pi, pi minus e divided by pi are not known to be rational, algebraically irrational, or transcendental. We don't know which one of this number lies on this. If you Here's the fun part. If you're able to solve one of this, you may as well go to the PhD program, and you can get a PhD degree
You
from
can
solving
get
this.
field medal, in fact.
No, I don't know about field medal, but at least you can get a PhD degree in math if you solve one of this
Very easy.
easily.
Ah.
I'm not kidding. Is
Oh,
it
that's
true?
cool.
Like,
Okay, so I guess that uh, this kind of a PhD degree can help us to apply in OpenAI.
I don't know about that, but
I think you
why?
can apply in um uh you know s- school grade. No,
I
no,
mean, if
no.
you can apply to MIT for PhD program, you were able to solve this, I guess.
No, I mean,
Probably.
Andra means after you get the PhD,
Oh,
then you can
oh shit!
apply
Okay.
for high school.
High school. Wow, why? Oh, what?
I-
Yeah,
Well,
but in the end, I mean, it is hard because it is a hard question, but the problem is not so hard to understand it, right? I mean, you just need to know if E times I is actually here, here, or here, right?
Mm.
Is it close under here? Is it close under here? Is close under here? Something like that. And that's why it's kind of like beautiful, you know. The problem is elegant. However, it's hard, you know. However, it's still hard. Thank you. That's the beauty of math, actually.
All right,
Well,
so
thank you so
beautiful,
much,
man.
Yeah, it's such a pleasure to have you here. You already presented a lot of, I'd say, knowledge. Actually,
Yeah.
inside knowledge. You already.
Actually, I want to thank all of you from joining this podcast because it's already 1 year.
Andra hasn't 1 year though.
Oh yeah, 1 year, but we included in this. Oh, I mean, this is for podcast, I guess. I
But
mean,
we
we
are
started.
officially in December and it is first in Twitch at first.
Which
Really? I don't.
Yeah, the first
remember.
time we did it, it is in the Twitch.
No, the November one actually from YouTube.
Oh,
It's actually in November. No,
wait, let
the
me
first
take
one.
a look. Let me take a look. Oh, really?
Yeah,
Oh, I think I'm wrong.
check it.
No, I cannot check it because my.
Oh yeah.
Can you
It's
share
in.
it? Can you share it?
Yeah. I'm trying to share this.
uh,
Oh.
but does that mean that actually Sunday podcast was already
Oh
established?
yeah, that's right. That's right.
Actually,
Oh,
it's
it is
actually
literally. Oh my
literally
god, that's
today.
really crazy. You know when I see this.
So yeah,
Okay,
Yeah,
it's
it-
literally today.
does that
So
mean that actually Sunday podcast was established earlier before I got joined this?
that's true.
Yeah.
But I included you because you are a regular member of this podcast, you know, even though you are late.
Yeah, of
Yeah,
course.
so
Andra
I
is
made this
welcome, of
artwork.
course.
Uh,
There's three of us.
So the left one should be Rendia. The
That's true.
middle one is me because I think it is server related.
So for related.
And then
so you are in the middle.
yeah, I'm in
And-
the
and
middle,
the-
I guess. And
Oh,
you
and then
of
there's
course in the left right most.
That's
Oh yeah,
true.
that's really great.
Well, I mean, I thought I would show this, but it's fine, I guess. Yeah. So this is some kind of artwork if you
Wow,
want to
it's
see.
kind
yeah.
of crazy.
It's,
It's literally today.
It's identical, actually.
Right? I mean, it's crazy, right? It's 26th November. It is today, 1 year after the first podcast.
All right, it's
I
time
s-
for Sumarokon, maybe.
I want to, but maybe in the end of year.
I cannot, Andra. I have still assigned. I still have
Oh, yeah.
assignments.
You know
Oh.
what? Like I remember that we both have this Google Docs containing the topic that we want to show, but we don't use that anymore.
Oh yeah, that's right, Rendia.
I
Yeah.
know.
Why did we don't use?
I don't know. It's too. I mean, it's just not that we don't plan too much. I
Yeah, we
guess.
don't really want to think. Yeah, we
Yeah.
don't really. Yeah, that's right.
This is-
that's right.
Yeah, I will send the picture if you want to. And it's just
All right, yeah, you may send it.
yeah, it's cool. So that's it. Thank you for. I mean, I must say thank you for all of you
Yeah.
that remain consistent
Yeah,
in
that's
this
really
1 year.
crazy, you know, because first of all, when I start this kind of community, I start with 3 groups of friends, and
Really?
So, who are them? Who are they right now?
so one is from my high school friends,
All right.
and the other is from my college circles, and finally Randia.
Oh,
And
okay. But
somehow-
so where are two other people going?
So those 2 groups, other 2 groups, just we don't live streaming like this one. We just met
Mhm.
in the Google Meet every once a week, but
Ah,
That's
somehow we just at least I tried to trigger the group, but nobody kind of respond in a
Respond.
Nobody
and,
responded you around.
after 2 months, after a month, 2 months, 3 months, they don't respond anymore.
Hmm.
So I was like, oh, I guess there wasn't really those people are
Yeah.
quite busy with their
Uh,
Yes.
uh,
quite busy with
They
their
can't.
stuff. So
Well, we started with just as a podcast, and we'll continue with how to tech. I remember this one. I realized that you are serious about this podcast, Adil,
because I
because you
like
met this,
them.
yeah,
But
thumbnail,
nobody, I don't use it anymore.
and then small thing.
all right.
I can just start
It was started when Adil was about man.
about what?
Adil has grown his own hair. That's crazy.
Yeah,
Oh
I mean,
yeah.
Andra start 1 month after we start the podcast. I
Oh
remember
yeah, yeah. Andra only start in the
next month,
yeah.
and you were bald.
And I went bro, like literally, and you literally make me the only person in there, and every one of you turn off your camera.
Oh yeah, remember? Yeah, yeah,
I
because
was
the
the only
signal
one.
was bad, and yeah, and then we continue for
And
Silicon
I
Tire
think
list.
it has the most view, I guess.
Is it 22 views? Yeah, like
Yeah, I
no,
think.
no, Silicon Tire list also
I
22
saw. Oh
views,
yeah,
80 view, 6 view. I mean, we don't have many view.
yeah. Who cares?
Who
Oh no
cares,
no
man? We
30.
just,
Oh no no. It is different.
it is you.
It is different. It is mine.
Mhm.
Oh yeah. Oh no no.
Oh no, 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 no.
Randia is the most. Oh jeez.
Yeah, remember this is using
One
air.
is. Oh
It's
yeah.
sad. I
Andrea.
mean, Andra, you should join in. It's crazy, you know. I show you showcase is a good one.
I voice cloning on it.
Yeah, I voice
You,
Connie.
oh, okay,
Yeah.
so yeah.
I remember
Oh
when
no
we
no. Oh
debate.
no no. Red. Our design
Uh,
pattern still relevant is the most.
oh shit! All
Oh
right,
actually it is your video.
it's
The-
my video.
okay.
Means I
Maybe
am.
you are really good at choosing topic, I guess.
I mean, it doesn't matter really, but
Yeah.
but to be fair, the one that I like is my favorite ones actually. First of all, this one conflict resolution technique.
What? Sorry, seriously?
Yeah, I really like this one. And the second, the second favorite one is actually Andra favorite about the importance of 21st century.
Oh yeah. You know, Ren.
Because
Yeah.
hmm?
I still remember in clever security mechanism when we
Yeah, we
talk about
debate.
that one is quite fun, you know.
Yeah, we debate because I don't. However, I think you were right in some way. I think I was.
It is about
Yeah.
hashing, right? No, no, not hashing,
Yeah.
but kind
As
of
about I don't know either actually.
you
Like
know,
is
like the key part there,
yeah, the key
encryption and signature. Signature.
yeah, signature for asymmetric one.
Yeah.
I guess. Yeah,
That
yeah.
one is kind of funny.
I think if I were the second one will be first one is your conflict resolution. The second one will be Andra oil. The third one, however, is going to be distillation and gas absorption. I think
Yeah.
that's for the three main video that I like podcast that I like. How about you guys?
Uh,
Adil maybe is
Andra first.
Andra, what do you like this?
my um
Do you have favorite or
okay.
one is okay?
Maybe cybersecurity, maybe the first one.
Security.
Yes.
Which one?
So
Oh,
that one, that one.
yeah, that
Right,
one.
and yeah, all right. So yeah, just scroll up that kind of videos.
Critical thinking is cool too.
I think we should talk about this later on, Randy.
Yeah, it's
Not
already
today.
yeah. No, okay, but yeah, it is not today I guess, but it is kind of interesting. So congrats for all of us, which consistently maintaining this podcast for 1 year, and yeah, that's for me I guess. Yeah,
Alright. So, Andra, please stop it. You are the host for today.
yeah.
All
Can
right.
you?
In order to celebrate around 1 year anniversary, yeah, we should be of course grateful for our God Allah Subhanahu wa Taala that already
It's true.
yeah made us to be like this and keep sharing the knowledge without hesitating for anything.
Hmm.
Yeah.
And thank you for today's podcast. And I would like to close today's podcast or meeting. So, assalamualaikum